GridThink is an American company that develops and commercializes the world's most advanced power-to-gas technologies. GridThink specializes in making integrated energy make business sense. GridThink has operations in Seattle, Washington, and Cheyenne, Wyoming. The GridThink Fire Jar Development Center in Cheyenne, Wyoming is a state-of-the-art engineering facility that is fully equipped for P2G pilot process development. Conventional energy storage systems are episodic in nature. When a battery gets full, it must be discharged before any additional energy can be stored. Our fire jar process stores electricity in the chemical energy of ethane gas. This allows storage and recovery to occur independently and without the capacity limitations of conventional methods. The ethane can be stored indefinitely and is also useful for mobility and heating applications. Storing ethane is easier than storing natural gas. No cryogenic handling is needed with ethane gas, which is easily liquefied at room temperature in 50 bar. Ethane handling and storage equipment is readily available. Stored energy is recovered as electric power by burning ethane in combined cycle turbines. Fire jar technology offers unmatched round-trip efficiency, achieving over 150%. Energy stored in ethane is versatile and can be used as a fuel for land and marine transportation. Ethane can also be used as a heating gas, either alone or mixed with natural gas. Ethane is a perfect P2G product. Ethane has 1.8 times more volumetric energy density than natural gas. Ethane is easy to liquefy and can be stored at room temperature at 50 bar pressure. There is no need for cryogenic equipment with ethane. Liquid ethane has 85% of the volumetric energy density of gasoline. By using ethane, the Fire Jar P2G technology can provide over 150% round-trip efficiency for energy storage. Ethane provides a crossover to the chemicals industry because it is an important feedstock for industrial chemicals such as ethylene. The GridThink Fire Jar P2G technology uses modules that are rated according to nominal power input. GTI's current fire jar module is rated at 5 kilowatts, and many modules can be used together. This fire jar module is compact and easily handled. Each 5 kilowatt fire jar module can store at least 0.85 MMBTU per day in the form of ethane gas. GridThink is currently designing a larger 50 kilowatt module that will be able to store at least 8.5 MMBTU per day as ethane gas. The electrochemical production of ethane was first observed in 1834 by Michael Faraday, who used potassium acetate and a battery. The electrochemistry was more thoroughly studied by Hermann Kolbe starting in 1849. Kolbe was able to use acetic acid to produce ethane, and this electrochemical process is named after him. Acetic acid is a common industrial chemical. In the Kolbe reaction, 2 acetic acid molecules are electrochemically transformed into ethane, hydrogen, and 2 molecules of carbon dioxide. The yields of ethane are very high, usually over 95%. Carbon dioxide can be captured as a high-value chemical product called PCC, or as a pure gas. Hydrogen is separated in most cases by normal methods and can be used as a fuel or sold as an industrial chemical. Existing power-to-gas technologies suffer from low efficiency, as much of the energy is lost before gas ever reaches the turbine. The fire jar process works by using chemical energy to enhance the incoming electrical energy. The result is that instead of returning just 1/3 of the stored energy, we amplify it and return 150%. GridThink Fire Jar technology uses an array of electrodes inside a pressure vessel to allow high power operation. Electrolyte containing acetic acid is recirculated from a reservoir over the electrode array, where it is converted into product gases and cascades back into the reservoir. The product gases collect in the headspace of the reactor vessel and leave through a pipe as a product gas stream containing ethane, hydrogen, and carbon dioxide. The process is continuous, with more acetic acid being added as it is consumed. The product gas stream is treated by an external physical plant. The fire jar can operate under pressure depending on the requirements of the external physical plant. For example, if a Benfield process is used to remove carbon dioxide, the best operating pressure is 20 bar. Because the fire jar equipment is modular, it can be housed in convenient formats such as shipping containers. A 20-foot shipping container will hold 10 50 kilowatt fire jar modules with a nominal electric power rating of 500 kilowatts. This shipping container can process 12 megawatt hours of electrical energy per day, producing 85 MMBTU of ethane per day. GridThink's fire jar is the centerpiece of an economic ecosystem that coherently links several different markets and supply chains together. Elements of this ecosystem include transportation and distribution, renewables integration, chemicals production, and a supply chain that eliminates the need for imported carbon sources. Ethane produced by the fire jar is easily stored because it liquefies at room temperature. Ethane can be transported as a gas or liquid in pipelines. Stored energy in liquid ethane also can be transported by ship and marine transport, by tank truck or ISO container, or by tank cars on trains. Once the energy stored in ethane gas reaches its final destination, it can be recovered as heat or burned in a combined cycle turbine with 150% round-trip efficiency. The fire jar process is very clean. There are no NOx or SOx pollutants nor particulates produced. Recovering the stored energy by burning ethane is also a very clean process, producing only carbon dioxide and water. Fire jar is a green technology that can become key to reducing the pollutants that are common in areas where coal is used extensively for heating. Energy storage is also critical for integration of green renewable power from solar, wind, or hydroelectric assets into the power grid. GridThink has the ability to link the chemicals business with energy storage using P2G. Ethane, hydrogen, and carbon dioxide are all important feedstocks for the chemicals industry. Hydrogen is used in many important chemical processes and in refining. Ethane is often converted to ethylene and used to produce plastics. Carbon dioxide has particular value for creating precipitated calcium carbonate, usually called PCC. PCC is used in a wide range of consumer products, from toilet paper to cosmetics. The supply chain for acetic acid is an essential piece of the fire jar ecosystem. Acetic acid is a common industrial chemical that can be made from a wide variety of carbon feedstock sources. Almost all acetic acid is currently made using a Cativa process from methanol and carbon monoxide. Syngas is used to produce the methanol and carbon monoxide feedstocks. GridThink has a process for making acetic acid that is more cost-effective than the Cativa process. This process is called kilobox and uses wet ethanol as feedstock. Ethanol for kilobox can be produced from syngas or fermentation. The kilobox process is based on a direct alcohol fuel cell and has been demonstrated at a pilot scale. The kilobox process also requires carbon dioxide and makes large amounts of PCC as a valuable byproduct. Kilobox can convert different alcohols into the corresponding carboxylic acids. As a result, other valuable chemical products can be obtained from the same kilobox plant that is used to produce acetic acid. Both methanol and ethanol feedstocks for acetic acid production can be made from syngas. Syngas for this application can be made from coal, agricultural silage, processed sewage, municipal solid waste, and many other carbon sources. As a result, imported carbon sources, such as natural gas, are not required for the fire jar process. Because the fire jar P2G process links the chemical and energy storage industries, a positive feedback loop can be established in which the acetic acid cost goes down as the demand for fire jar goes up. The virtuous cycle begins when lower costs for energy storage using the fire jar process increase the demand for energy storage. This increased demand for energy storage, in turn, increases demand for acetic acid. Increased demand for acetic acid increases production of acetic acid and lowers the cost. Lower acetic acid cost increases demand for energy storage, and the virtuous cycle continues. Over time, the virtuous cycle acts to drive up acetic acid production and drive down the cost of acetic acid as demand for energy storage grows. A virtuous cycle between two previously unconnected markets can push open new markets much larger than each individual market by exponentially increasing demand. In this case, both the chemicals market and the energy storage market are large billion-dollar markets. However, combination of the two markets by the fire jar P2G process creates a synergy that results in a new market which is much larger than the chemicals and energy storage markets combined. It is estimated that the size of this market in the United States is approximately $300 billion. The large markets for fire jar energy storage arise from the ability of P2G to scale into the terawatt-hour range and to provide energy storage for a very wide range of durations, including deep seasonal storage. Some of these markets are cost sensitive, and the virtuous cycle between FireJar and the supply chain is a key capability to capture cost sensitive markets and drive growth. GridThink seeks to build one or more pilot-scale demonstration facilities that can produce 550 cubic meters of ethane per day. A pilot facility of this size will require 40 5-kilowatt FireJars and a nominal input power of 200 kilowatts. This FireJar facility can operate well outside its normal power range and will support input power levels between 50 kilowatts and 1 megawatt. Post-processing operations for the P2G product will be selected by the customer. GridThink will achieve low-rate initial production of FireJars during the pilot plant phase and will design manufacturing processes that allow full-rate production in the future.